The instructions say, I forgot. Simplify. Assume that all variables are positive when they appear. That doesn't, oh, variables, okay. Any ideas? Does anybody notice anything right away? If we're just supposed to simplify? I noticed something. What's your name first? Karen? Yeah. What do you notice first, or what do you want to do? Factor what?
Factor out x cubed for first fraction. As a denominator.
This part?
Yeah.
You can factor out an x cubed. Yes. Anything else? I mean, it says simplify, so factoring, hopefully stuff will cancel. There is a difference of squares. This part is a difference of squares. We can factor that. Anything else that anybody notices? Did I copy this down right? Yes?
Yeah. Maybe we could get rid of the radical.
You can only get rid. Are you thinking because it's like square root times the square root?
Yeah, we can make just get rid of it and make it like parentheses out from the up. That covers the whole thing and then put a square.
Oh, I see. One radical and then put both of these on the inside. Is that what you're saying?
Yeah.
Yeah, we could do that. If you didn't notice that, I think that probably would be best. I'm going to do that. I'll do all the things that you guys were saying, so that's good. First, in this numerator, we'll factor out, what was it, an x cubed? And we have 2x plus 3 left over. We have 2x minus 3 in the top because we didn't do anything to that. The top of this one will stay the same. This part right here is a difference of squares. It's 2x plus 3 times 2x minus 3. Ooh. And then we have the radical over everything. If you're multiplying two radical expressions, you can put the radical over everything and multiply the insides. That's a property of radicals. We could actually consider this as like just one division bar. What happens? 2x plus 3x. Oh, you could say quantity squared for this stuff. Is that what you're saying? And you can cancel. Here's the thing. When it's written like this, it's correct. If you put it over like one division bar, you should write it, whoops, with parentheses around it. That way you know it's not a 3x. It's 2x minus 3 altogether times x. So you could distribute that x, or you could cancel it out. We're allowed to cancel it because there's no addition in between here. So those are gone. What else cancels? Yeah. That goes away, and we have an x squared there. So I'll rewrite this. So on the top, what do we have? Yeah, just 1. And on the bottom, we have x squared times 2x plus 3 quantity squared. We can actually do more. Does anybody have an idea? What's that? Both of those things you don't need to do. Well, if you split up the radical, the square root of the top and the square root of the bottom, you can split up the radical between the numerator and denominator. If you take the square root of 1, that's just 1. So the top is just 1. So what he's saying, what's your name? Sam. And what's your name? Felipe. Sam. Felipe. Okay. You're in this video forever now. If you could square root the bottom, I'll show this part. 2x plus 3 quantity squared. So the square root of 1 was just 1. That's why we wrote it as a single 1. the square root of that multiplication. We could also split up the radical there, because the same way where we took multiplication of two radicals and put the inside all together, we can reverse that and take the inside and separate that. It'll just be x times 2x plus 3. Do we see that? Does it need? So it'll be x times 2x plus 3. So the last simplification that we could do is distribute. And that would be 2x squared plus 3x. I don't know what else to do with that. So.